Coming up on TekThing this week, let's talk about 64-layer V-Nand flash, 60-terabyte SSDs, and why enterprise drives aren't a great idea for home users. Yep, we got the Flash Memory Summit report, headphone DACs don't cost a lot of money, and Intel Developer Forum 2016. So much coming up on TekThing. If you get something useful out of this episode of TekThing, please consider contributing to the show at patreon.com/TekThing. We're brought to you by viewers just like you. Thank you so much.
I'm Shannon Morse.
And I'm Patrick Norton.
And this is TekThing, where we have something useful in every single show.
And toys. Sometimes we have toys.
All sorts of toys, like Arduinos.
Arduinos are toys? I thought those were serious development tools.
Oh, dude, they're totally toys.
Speaking of toys, or at least faster internets, worst segue ever. Big shock. Wall Street Journal says Google Fiber has discovered that laying fiber is expensive and takes forever.
It took them long enough to figure that out.
Well, I guess they're rolling out in almost a dozen cities right now, but they, like 6 years, 6 cities, and they're now experimenting with fiber to wireless. Not too long ago, they bought Bay Area provider WebPass, which essentially does wireless to apartment buildings and then distributes inside of the apartment buildings.
Yeah, you got to watch out for that and make sure that your computer is tied down and secure. You don't want to get on that internet, that shared internet, without tying your computer down. I learned that the hard way when I was in college.
But cable is shared internet, but not, WebPass has a pretty good, there are a lot of people who would be trying to pillory WebPass if they didn't have their stuff together.
Oh, yeah.
What's really cool, though, is Google's experimenting with experimental transmitters attached to street lamps in Kansas City.
Oh, weird.
Well, I mean, apparently they had complaints like people had their lawns dug up, right? You know, gas pipes got hit, and it takes forever to bury cable. So
that's true. I actually have some friends that live over in Kansas City, so I'm going to have to ask them about their input on that and see when it actually comes into place. I would love to see if those things actually get put into place on the lampposts.
Yeah, well, okay, here we go. Apparently Google Fiber reached 6 metro areas in 4 years.
Wow.
But still, it's, there's still a whole lot more of the United States to cover. On the upside, I think Google's efforts in this area has certainly pushed, cable and other providers to keep their prices down or to offer better deals.
Yes.
We hope.
More deals, good for consumers. And the Intel Developer Forum took place in San Francisco this week, and Patrick actually dropped in for the keynote, so let's go ahead and find out what is coming up from Intel.
Merged reality, Intel powering the cloud and billions of smart and connected devices. So what exactly happened at Intel Developer Forum 2016? Well, Intel CEO Brian Krzanich barely mentioned, CPUs, the thing we usually think of being tightly tied to Intel. But if you're thinking about a new laptop, you might want to wait for the 7th gen Kaby Lake processors to show up in laptops this fall. Intel spent most of the brief time they talked about CPUs talking up the Kaby Lake 4K prowess with lots and lots of discussion of 4K footage and its ability to play it back. But I was caught by the Dell XPS laptop with a 7th gen Core i5 Kaby Lake processor playing Blizzard's Overwatch with the Intel onboard graphics. Not the most stressful 3D game, probably not near the highest settings, but it looked playable. That's impressive for a recent 3D game running the graphics from an Intel chip. The new processors are shipping to PC manufacturers right now and will be available this fall. Along with improved 3D performance, you'll find USB-C Gen 2, native HDCP 2.2 support, and yes, all that 4K hardware that handles HEVC main 10-bit MVP9 10-bit video decoding, because, eventually you're going to have a 4K screen. Mostly, though, Intel's keynote was Intel inside hip stuff, and I gotta say the Project Alloy all-in-one VR headset looks pretty slick. A cordless VR headset completely contained all the compute, sensors, graphics, dual RealSense modules, the batteries, all inside of the thing you put on your head. It's supposed to be balanced, completely self-contained to deliver a virtual world that makes it easy to walk around. To me, said Krzanich, that's what virtual reality means. He also said virtual reality is mainstream, but I think it's a little early for that. Intel won't make Alloy themselves, but it sounds like partners will be selling it around the second half of 2017. While the self-contained no-tail aspect is compelling, Project Alloy's ability to map your hands and fingers inside a VR environment was really amazing. Full sensing, 5-finger tracking. It was impressive. A little blotchy in the demos, but it looked like it was tracking the wiggling fingers all right. Intel also demoed their idea of emerged reality, bringing real world into VR and vice versa by bringing a dollar bill into the VR environment and using it to interact with a golden lathe. They were sculpting with it. It was pretty slick. Then Microsoft showed up and promised that next year, all Windows 10 PCs will have Windows holographic, because it's mainstream. And then they demoed Outlook in VR. Really, Outlook. And then HoloTours, which were a little more impressive than Outlook, but probably a lot more impressive than Word. Another big theme was building a world of visual intelligence all around Intel's RealSense technology. Now, if you don't remember RealSense, it's basically a box that combines a 1080p HD camera, an infrared camera, and an infrared laser projector that sees like the human eye to sense depth and track human motion. Typhoon's unique. We saw that back at CES. That's the drone that can navigate around objects by itself. That's actually on sale as of yesterday for $1,800 bucks. Intel talked up the Aero platform for UAV that combines RealSense tech, LTE comms, PX4 drone code, and air map all in a single unit for $399, and Euclid, which is a RealSense module for robots. It integrates compute, communications, and the RealSense cameras in a space the size of a pretty small candy bar. Apparently can pack the batteries too. Intel was all over the map. There was a discussion of their work on autonomous driving or autonomous automobiles with BMW. By 2021, you'll have the ability to sleep while the car drives or just send the car off on its own little mission. GE showed up to talk smart cities, and Intel has an obsession with the growing need for masses of offline or online storage. The idea was that by 2020, the average internet user will generate 1.5 gigabytes a day, a smart hospital 3,000 gigabytes a day, an autonomous car 4,000 gigabytes per day, airplanes 40,000 gigabytes per day, and smart factories a whopping 1 million gigabytes per day. So petabytes are in your future. Oh, by the way, the Maker and Internet of Things inventor-friendly Joule 550X was debuted there. The processor kit, which will seamlessly transition from prototype to scale. It comes in at a pricey $369, hardly Raspberry Pi turf, but hey, Joule has 802.11ac, support for RealSense, a quad-core Atom processor, 4 gigabytes of RAM. It's essentially a full-blown computer in a fairly small board. For me, the 7th gen processors and Project Allyn were the big highlights, and I'm going to try and find somebody using Intel's Aero for UAV, and I'm really curious to see if Project Allyn ships and what kind of support it's going to have, because games make VR, and if there's no game or application support, it's kind of useless to own the headset. By the way, we'll be talking more about VR you can buy today on next week's show. Got a question? Are you curious to see us review something on TekThing? You got a tip or an idea? Fire them out to ask@tekthing.com, or you can tweet @TekThing, @Snubs, or @Patrick Norton. And by the way, if you want to be part of the crew that makes this show possible, we can make that happen. Just head over to patreon.com/TekThing. $1 a month will make a difference, and you'll get access to our patron-only build videos and more. Hey, everybody, thank you for your patronage. You make the show possible no matter how you contribute. Flash Memory Summit took place last week in Santa Clara, California, an annual gathering of pretty much everyone and everything that is awesome in storage. And our favorite storage editor, Mr. Allyn Malventano, PCPer.com.
Hey, buddy.
Hey, we stole his car keys, and we won't give them back until he talks about what happened at Flash Memory Summit last week, or this weekend.
There was a few things.
So we've gone from like 32 layer to 48 layer V-Nand at Samsung, and they announced 60 layer V-Nand?
64 layer.
64 layer.
64 layer, yeah.
What does that mean in terms of buying drives?
Hopefully that means that they'll get cheaper, but they didn't get cheaper when it went from 32 to 48, so I don't know what's going on there. Eventually it's going to get to a point where these things are so dense where they just become cheaper and cheaper to produce.
They're talking about like, was it 25 terabyte? No, I'm sorry, 32 terabyte 2.5-inch SSDs.
Yeah, so last year they talked about a same exact style, form factor, what have you, 2.5-inch, I think 15 millimeter thick. It's meant for enterprise. You know, it connects via SAS. It's not even like a PCIe thing. So the idea is put a whole bunch of really dense things in a chassis and just have a massive amount of flash memory storage. It's like super, super fast. But last year they had that same exact form factor and model in a 16 terabyte model. Right. And thanks to the 64 layer flash, basically it doubled the density per die. So they're putting the same number of dies in this thing, it just doubled the capacity.
You say die, you essentially mean each individual memory chip that's mounted on your M.2 or whatever the PCB inside the SSD is.
Yep, like there's chips, which is actually like the little die, the thing they cut off the wafer, right? And then it goes into packaging, and they can actually stack those dies within a package. So they typically go up to like 16 high. Okay. Within a package, within that plastic thing you see soldered onto the board.
Nice.
Yeah.
Is this going to come out in the next 3 months, in the next 6 months, before the end of the year, or is this just an early announcement from Samsung?
Samsung is kind of mixed on how this stuff comes out. The 48 layer stuff, when it launched, It came out in like a mobile, like a T3 external SSD, and it let them put in a relatively small thing. It was like a 2 terabyte, like really small external drive. That came out right away, but we haven't seen that same 48-layer stuff come out in things like the 950 Pro, which was supposed to launch in a 1 terabyte model, thanks to that 48-layer stuff, and that still hasn't surfaced. So they kind of stagger their rollouts sometimes. You know, it's kind of weird the way they do that. But some of it will be available soon, some of it probably later on for like mass production or whatnot, you know.
But so basically, whenever they run out of the existing chip pile, they'll start migrating.
That's the thing, right? Because they have, like, that's a huge investment to get all of their fab and everything spun up for however many layers it is, right? Once that's set, it's basically set in stone until they kind of like tear into the fab and like rework how the whole process works. So it's a lot of money, it's a lot of investment. So once they've got the chain going on something like 32 layer, they're going to milk that for as much as they can and as cost effective as they can, right?
So in theory, if the yields are high enough, if all of the chips off of the, if all the chips off the big wafer are functioning, then it should be considerably less expensive for them to manufacture, like,
it should be
60.
The 64 layer, yeah. The trick is that to do the higher number of layers, it becomes more complex, like manufacture-wise. So there might be more steps through the process. The wafer might take longer to make it through the fab, which results in like, less cost-effective as far as like their production costs. So, it's kind of like 6 in one, half a dozen in the other, a little bit. But it should start getting, I mean, we've seen SSDs getting cheaper over the years. It's just not, when you see them do something like double die capacity, that just doesn't necessarily translate to, oh, my SSD is now half the price.
Wouldn't it be nice, though?
It would be wonderful, but that's just not how it works.
We've heard about Crosspoint from Intel. Now, one of the big announcements last week was Micron talking about Crosspoint, Micron and QuantX Crosspoint. And they had a prototype SSD. What's going on with that?
So they did 2 announcements. The QuantX is the branding for Crosspoint under Micron. All right, so that out of the way first. Intel, a few months back said Optane is our branding for Crosspoint. So they each have their own like sub-brand name for that stuff, right? It's the same technology that's going to be in either one of those devices because Intel and Micron have jointly developed Crosspoint memory. And they're going to jointly produce it in their fabs. They do the same thing with flash memory. So the cool thing about the Crosspoint memory is that it's just really damn fast.
Really?
Yeah.
Just in terms of dropping an already low latency just completely to the floor.
There's that, and it doesn't have a lot of the limitations that flash memory have as far as how you write to it. So you can't just write a single byte of data to flash memory. You have to write it a page at a time, and to erase it, you have to erase a block at a time. And you end up having to play a lot of musical chairs with your data once you try to continuously write random things to a drive. This Crosspoint stuff is byte addressable, so you could you could erase or overwrite or what have you a single byte of data anywhere within that. So it acts a lot more like RAM in that respect, but it's persistent. So when you kill power to it, everything gets saved, right? Everything's still there.
When we're looking at the sort of the diagram here, like this U.2 mixed use, 4K random, 70% read, 30% write.
Yeah.
What are we looking at in terms of here? Because this looks really impressive when you're looking at the QuantX stuff over here in the corner.
So that orange line along the bottom there is actually, I'm pretty sure it's Micron's 9100 series Enterprise SSD, which we just reviewed at PCPer.
Which is pretty fast.
It was the fastest NVMe part we've tested so far. Now compare that with this stuff, and what you see is that line, the horizontal line across the top of the chart there, that's where it's saturated because the interface is just saturated. PCIe, four lanes of PCIe are just going as fast as you can. And the max theoretical you could do for 4K random is 900,000 IOPS. And it hits that number, there's just no more room to squeeze anything through the bus, basically, at that point. But the key there is that it's able to do it at what's called a very low Q depth. And a Q depth is how many commands ahead the SSD sees coming or knows is coming, right? So your operating system can say, okay, I'm going to want the following X number of addresses. Go fetch those for me, right? And that's your Q depth. NVMe part, you'd have to tell it a whole lot of those things ahead of time in order to like wait for that flash to be addressed and fetch its data from within each die, pull that data out, send it over to the controller, get it back to the system. And so it's basically a very parallel operation that doesn't spin up to full speed unless you have a lot of operations going on at the same time. The Crosspoint stuff is so fast that and it's so fast at turning around a request, as well as how sheer speed of like lookups and how fast it can transfer data, that you end up with that result where it basically just goes straight up with only 4 requests ahead, basically.
When you're looking at a chart like this, most people are still looking at storage in terms of like what's the bandwidth, what's the throughput. When you look at IOPS, what's an IOP when you compare that to sort of like an old school storage speed measurement? Although IOPS isn't exactly new.
It's kind of like a seek time for a hard drive. When you used to talk about seek time, and that would be in like 10 milliseconds or whatnot for a hard drive. That was how long the hard drive took to go fetch just one piece of data, right? It would have to move the heads to a right place on the disk, wait for the disk to turn around and actually read, for that information to pass underneath the head of the drive, sort of like a record player, like playing a song, right? That's what an I/O is. But then when you get into SSDs, like hard drives will do like 100 IOPS, something like that. That thing does 900,000
IOPS.
Yeah. So just think of the difference there, right? And the idea is that moving forward, it's going to come out for enterprise stuff first, obviously, but probably 2 or 3 years, you might see a little bit of that cross-point memory, like sitting alongside of a CPU, maybe, maybe as like a level 4 cache, or maybe it would get to the point where you can have your operating system just installed onto that thing.
Sure.
So now there's no such thing as hibernate anymore.
Because it just doesn't need to.
So why do you need to hibernate when you just turn it back on and it just runs the OS straight from that?
How convenient.
That would be beautiful, right?
I'm down with that.
Yeah. That would be good stuff. So things coming in the future, basically.
So NVMe is kind of the big step up on SATA, whether you're talking about like M.2 drives or U2 drives. What's the difference between NVMe and SATA? Is it the bus or is it the storage technology?
It's both.
Okay.
It's a different physical interface, because NVMe will typically be over PCI, whereas SATA is that's the physical interface. SATA uses what's called AHCI. That's basically the protocol. That's what the logic of like how the communication is done, right? Okay. AHCI was developed for hard drives. We're still using it for SATA SSDs.
Sure.
So to say we're stretching the technology beyond its limits is, a stretch, basically. So NVMe is a very low latency protocol. It's designed to reduce the overhead on the operating system for trying to handle all of those operations that are ripping through the drive, right? So AHCI is more like heavy on the kernel of the operating system, and it has to do more stuff on the back end just to even request a single I/O from a SATA SSD.
I need this bit.
Yeah, but there's a lot of steps that takes, right? NVMe is basically a different driver. It's a different like infrastructure put in place to talk to things that can just handle I/Os way, way faster.
So you reduce the CPU overload, you reduce the latency.
Yep.
Is there a noticeable real-world performance if I go from a SATA M.2 drive to an NVMe M.2 drive? Am I going to be like, whoa, this is faster?
It ends up adding up to that.
Okay.
If you just looked at any individual request, it's only a very small difference in the grand scheme of things. Like hard drive to a SATA SSD is already a huge jump.
Sure.
That's maybe not as much of a huge jump, right? But when you start talking about really having a lot of things hitting your drive all at the same time, you're running a lot of stuff in parallel, that's where it just starts to sing. And those little differences in time all add up because you're hitting the drive with a lot of requests, and overall the speed just goes way up.
You take an ounce off the running shoes, you take pounds off of the amount of weight, or dozens of pounds off the amount of weight you're lifting over the course of the race.
Exactly.
So that brings us to Phison's E8 controller.
Okay.
They're claiming they are delivering like NVMe performance at something closer to sort of a standard SATA price.
Yes.
Okay.
Their claim is that their controller costs the same.
Nice.
So if you had and Phison is they make the chips that go into in Kingston or whoever makes their SSD that you buy, they'll have different controller technology, right? They can come from different sources. But Phison is one of them, and their goal was to make it as low cost as possible, right? They wanted, how can we make this thing cheaper? Well, turns out a lot of the M.2 SSDs that are out right now, they're a little on the costly side, right? Part of that is due to the controller has to be able to talk to PCI over, first of all, it's a very fast PCI interface in the first place, PCIe 3.0. That's not a cheap thing to make, is like a thing that can speak that quickly over PCI.
Sure.
Most of those SSDs have 4 of those lanes worth of PCI. But due to the flash memory technology only being so fast, they're only really using about 2 lanes worth of speed.
Oh, wow.
Right? So Phison said, okay, well, what happens if we just cut out 2 of the lanes, and then we'll spend most of our time saturating the 2 that we do have to use. Now we only have to put half of the number of those channel controllers on the part, so it's cheaper to make.
Nice.
Right? And due to that, they're able to drop the price to either very close or matching a SATA controller price. So you could potentially see a Kingston, or any other reseller SSD using PCI and NVMe. It'd only be half the number of lanes as like a 950 Pro, but it'll still be a very, very fast part, and it should, in theory, cost the same as a SATA SSD.
For the most part, Samsung, Intel, most of the sort of first-tier SSD manufacturers, they're trying to use their own controllers in-house for the premium
Sure.
drives.
Yeah, they typically do that. Okay. Well, a lot of the SSD makers, that's the pipe dream for an SSD maker.
Sure.
Is you want to have the RAM come from you, if there is any RAM. Some parts that were launched at Flash Memory Summit, they were talking about DRAM less. So they designed the controller with a very small amount of RAM just inside of it, so you don't even need to put a RAM chip on the SSD anymore. Right? Trying to minimize as much as possible, right? So the idea is, controller, some flash, some pins, plug the thing in and go, right? But yeah, Samsung is like front to back. They make all their stuff that goes into it, all the things that go to make up that SSD, right? And that's great for them. Intel does the same thing. Micron does the same thing. Toshiba does the same thing. They make flash as well, right? So you have a handful of companies that can do that. Everybody else has to source the parts from those guys and then try to piece things together and use things like that Phison controller.
Sure.
There's also Silicon Motion is another company that makes the third-party controllers.
And try to remain cost competitive or try to beat the prices of the major vendors.
They usually do a pretty good job because the other vendors are trying to recoup their costs from like producing all of those things, whereas the other guys can just try to get stuff, kind of on the cheap, right? And in a lot of cases, unfortunately, that ends up being like lower grade flash.
Right.
Right, because Intel and Micron, they're going to keep their best stuff for their enterprise SSDs and whatnot, right? And then whatever's left over, that's what gets shipped out, and then those guys have to go through and kind of pick through the scraps and find the good flash out of it and whatnot.
And see what's left.
Yeah, I mean, it works out fine because there's over-provisioning, there's like extra space on, any SSD has excess space, and so if you do have a bad spot on it, it'll just map it out and, send it to the scrap pile.
Is that the big difference between a fairly inexpensive 750 gigabyte Crucial MX300 versus a top of the line sort of Samsung N950 Pro, where it's like you're getting you're not getting the floor sweepings in the alternative brand, but you're not necessarily getting the best.
It's partially the quality of the parts, but I have walked through multiple SSD manufacturers, like the big companies that have all their parts in house. I've walked through several of their quality control or just like qualifying operations, where they'll have just like huge racks of different systems, and they will literally plug their part into every possible system, check everything, make sure it's compatible with as many things as possible, right? And they'll also have things where they literally like put them in a freezer or bake them in an oven, right? Basically temperature controlled environments, and run them at extremes of temperatures. And Intel even goes as far as to bombard their enterprise controllers with like accelerators. Because they're trying to simulate cosmic rays, because like you and me right now, like there's things just kind of floating around. Well, if it flips a bit in your computer, that might be horrible, right? It flips a bit in your SSD, you just like potentially corrupted some data. Also very bad, right? So these companies have like an enormous amount of funds invested just in testing these things and certifying them. And that's unfortunately what turns into higher prices, because somebody has to pay for that.
Got it.
Right? You end up with a higher quality part, but it costs more money. And it's not just like a lot of people think, oh, Intel's just jacking up their price, because no, they have to pay for all their operation that they have to do all that stuff, right?
I'm just envisioning now a particle accelerator hammering on the SSD.
Well, they don't own the particle accelerator. They lease it from somebody else. They like get some particle accelerator time, but I have seen a slide where they actually were talking, and I actually wrote about it like a year back, where they, and they made sure, the idea was to make sure that the firmware in their enterprise part would detect that a bit got flipped somewhere, and then shut itself down and go, okay, look, I'm bad, something happened. I don't know what happened, but it's bad. And so, and the enterprise SSD firmwares, there's a lot of folks out there that use, and they like to order enterprise SSDs and use them in their home system. There's note to the wise, or caution, or whatever however you want to phrase it, right? those parts typically are designed to brick themselves as soon as they see something squirrely going on. Whereas a consumer part would try its best to keep going.
Right.
Right? It might give you some bad data, but at least you're getting data. Right? Enterprise parts are like, well, if you're running an IT shop and you have huge racks full of SSDs and a whole warehouse and whatnot, you don't want to spend time troubleshooting the one that's a flaky every so often, right? You just want it to go out and just be done, right? So enterprise parts will do that. So be extremely careful using them in your home system. Yeah, you might be happy that you got this enterprise SSD that you think is awesome, but if there is a fault with it that somehow slipped through, it'll just brick itself.
So make sure your backups are up to date.
Make sure you're backing up. Yeah, if you're using enterprise parts, back up a lot.
One last question before we go. Seagate showed off a 60 terabyte SAS SSD.
Yep.
Obviously not a consumer part.
No, it probably costs a lot of money.
We were thinking, what, 15, 30 grand?
Probably. You probably just leased that thing, honestly.
Lease it.
Maybe. It's up there, and they were talking about that same model moving to 120 terabytes of capacity due to, again, announcements that came out at the show of like higher capacity flash, right? From most of the companies. They were all announcing like, oh yeah, we're doing higher layers, higher, more capacity per die. So that thing has 1,080 flash dies in it. Yeah. There's 80 packages, each one has 16.
How do they keep it cool?
It only draws like 20 watts.
Oh, wow. Okay.
Yeah. So flash memory, the power consumption of flash memory is really proportional to how much data you're moving through it, right? The idle's really, really low. It just kind of sips power, just like standby or whatnot, right? It's when you're moving the data. So that thing is only connected via SAS. So it's SAS 12 gigabit. I think it's dual channel. It's only able to go like 1.5 gigs per second. So if you move 1.5 gigs per second to that, or if you move it to a 950 Pro, which can do the same speed, right? You're dissipating kind of sort of the same amount of heat.
Got it.
Right? It's,
I was just thinking how hard, how ridiculously hot my little 128 gigabyte drive got, just moving a few gigabytes on.
That gets pretty hot, yes. I'll give you that. But you realize that's a 3.5-inch part. It has an awful lot more surface area on it to dissipate whatever heat's being made. Like when you plug those little flash drives in your laptop, there's no place to dissipate the heat.
Right.
Like there's not a heatsink on that thing. The heatsink is the thing.
Apparently I need more heatsink.
Yeah.
So, Crucial MX300, 750 gigabyte, one of your favorite sort of sweet spot parts.
And it's a limited edition.
Really?
Because they launched other capacities. I wrote a post up a few weeks back on that, I think. They launched new capacities that were like, they were oddball kind of capacities, like 525 gig or something, and 1,050 gig. So it's not just 1 terabyte even, it's 1,050. So the 750 was meant as like, okay, let's see, can we make this work with this new 3D flash? From IMFT, which is Intel and Micron, right? So they put that in there, it worked, and then they're like, okay, we're gonna like phase out the 750, we're gonna push in to the channel these other capacities, like, it's like around 250, around 500, and around 1 terabyte, which is more in line with what you're used to seeing, because 750 was an oddball number, right? So they probably had some kind of market pressure from people that got confused, like, is it 750 or is it 1 terabyte? What do you mean? Do I round up? Do I round down?
But it was, it was such a nice price. It was like under $200 for 750 gigabytes of SSD storage.
That's true, and the cost per gig should be the same.
Right.
For the different models, it'll just be higher capacity or lower capacity.
Samsung's still your go-to? Samsung 950, 950 Pros?
I like 950 Pros for if you want simple, elegant, you put this thing on your motherboard and you forget about it and it's just your SSD, right? Just realize you're limited to 0.5 terabyte. If you want anything more, my go-to for anything SATA is 850 Evo. I don't recommend 850 Pro because you're spending more money for extra performance. You're not going to get any more performance. Like an 850 Evo 500 gig or higher will saturate SATA in basically everything you do.
Got it.
So why move to the Pro model when you can get the same performance out of the 850 Evo part, which is about half the cost.
Don't go Pro unless you have NVMe.
There only is Pro for the 950. Yeah, that's all you get as a Pro. But if you need the capacity, 850 Evos go all the way up to 4 terabytes now.
I want.
It's a lot of capacity.
I want. Can't afford, but I want. Thank you so much, Allyn.
Yeah.
Ladies and gentlemen, Allyn Malventano, PCPer.com storage editor, and pushing the world of storage benchmarks. Go to PCPer.com, check out his stuff. Thanks again, man.
Thanks.
That was awesome.
We got a question from Luca, who is in Linux driver heck, and he emailed ask@tekthing.com. I just installed Fedora 24 on my new PC, and everything works except for the BCM 4352 Wi-Fi card from Asus. I tried Ubuntu 16.04, but the computer bricked and hanged when I tried to install proprietary drivers. I tried compiling the driver myself on Fedora, but that didn't work out too well. Every time I update the kernel, I have to compile it again if I even manage to compile it. Should I buy another Wi-Fi card supported naturally with the kernel and has open source drivers? Please advise. Greetings from Slovenia, from Luca.
I think it's our first Slovenian question.
I think so.
Woo!
Thank you for being the first. Yeah! Way to go, Luca.
I was gonna say, like, as the terminal Linux noob, and I've been a Linux noob for like 20 years now, it is always easier to use hardware that's supported natively in the kernel.
Oh yeah, yes.
Yeah.
That's like the TLDR version. So I actually figured something interesting out when I installed Ubuntu on my Acer machine. You can run a couple of different commands, and I'll show you what those are, just to make sure that your actual wireless driver inside your machine is working, like the hardware.
Or if your
so you can
operating
run,
system actually even sees
yeah, if it even sees it. So run iwconfig, and that will show you if you have a wireless driver available, and then run sudo iw, the name of that wireless driver, and scan, and that will let you know if your wireless hardware inside your computer can actually see any local wireless APs. And if it does, you will actually get a listing of any wireless APs in the area that it can see. So that's just like the starting point,
Right.
to make sure that the stuff inside your computer is actually being seen with your operating system. So from there, you can then move on to considering new hardware. Some hardware that I know a lot of hackers use whenever they use Linux, whether they're using Ubuntu, Fedora, Kali Linux, other distros like that, is called the Asus, or the Alpha AWUS 036 NHA. They use this for a lot of penetration testing, so you might want to consider something like this since it's very cheap, $28. I mean, how could you go wrong with that? It's a good one.
$28 for something that works may be priceless.
Yeah.
And it's not like a little nubbin that sticks in the side of your PC and stops working if you
No,
rotate.
it's like you Velcro it onto the back of your PC.
Yeah, it's.
But it works very, very well, and it has a nice big antenna on it.
We like nice big antennas. They
Yes,
make us
we do.
happy. Some folks have gotten that Broadcom 4352 chipset to work by apt-getting the BCMWL kernel source. And if you want to nerd out on that, if you go to Ask Ubuntu, they will give you some step-by-step instructions on that.
Oh, perfect.
Sudo apt-get update, sudo apt install. So I should say apt-get install. So
Yes.
yeah, I guess it would be like, start with the command. If it doesn't show up, try doing the drivers. If it does, then run the command again and see if the drivers actually made it run.
And if it's still not working, then consider some new hardware and then actually like purchasing something outside of what you already have.
It's so frustrating when you can't get things to work.
Yeah, absolutely. And also I would love to recommend again askubuntu.com. That's a great website for any kind of starter material that you need if you're new to Ubuntu or new to other Linux distros as well, because a lot of them are cross-platform. A lot of the information that they give you on askubuntu.com will work in other Linux distros as well. So definitely check it out if you're looking for some more answers. Mr. Patrick Norton received a tweet from Phil360 who asked, could you recommend a headphone DAC for a desktop PC for less than $200? Thanks.
Oh my goodness. Yes. Yes, I can.
Of course you can.
Well, it's
You're the DAC master.
I don't know if I'm the DAC master, but I got to spend some time at the Headphone gatherings this year. One down in Orange County, the big Can Jam gathering, and then they did a local regional gathering in San Francisco. If you want to hear a bunch of cool hardware, look on the Headphone website to see where they're doing regional gatherings. That way you don't have to travel to Colorado or SoCal. And I listened to every single headphone amp and DAC I can get my ears on. Oppo's HA1, it costs like $1,200. Some of the audio legends, Cavalli Audio, you can spend thousands of dollars on one of their headphone DAC/amps. The upside, and this is the best part, is that there are some great digital analog converters with built-in headphone amps for under $100.
Yes.
I have been a huge fan of AudioCliss Dragonfly for a long time. It's small. It's simple, and back at CES this year, they announced the AudioQuest Dragonfly Black. It's a third in the series of USB DAC app combos from AudioQuest. The original one that came out in 2012 cost $250. The one I bought out of my pocket, the Dragonfly 1.2, which is, it looks like a little USB thumb drive.
It's awesome. Yeah.
Delivered basically the same performance for $150. The black costs $99 and packs the same headphone amp as the 1.2 and a new Sabre DAC. All the Dragonfly DACs, they do what they call asynchronous or stream length code that prevents USB jitter from causing issues with the audio playback. Okay. That's a big audio nerd thing.
Yeah.
They also announced the Dragonfly Red, which costs about $200. That's for if you need more voltage to drive your big honkin' planar magnetic headphones. It's got a slightly better DAC than the black, but I'm not sure I can hear the difference without all of the listening. And it uses a digital volume control. They say it's bit perfect. Rather than the analog volume control found in the black and the earlier AudioQuest Dragonflies. And if you'll notice, this is plugged into a iOS phone.
Yeah, isn't that the lightning jack?
Yeah, both the Dragonflies will work with most Android phones with no TG cable or with iOS devices with Apple's camera connection kit. And apparently the voltage draw or the power draw is something like 24 milliwatts. Which is really, really low.
Yeah,
so that's a good thing.
That's great. So it's not going to drain the battery on your phone real quick.
No.
That's good.
At least hopefully not. This is Emotiva's Little Ego. That's on sale right now for $99. And presumably till they run out. I think they're closing them out. The Big Ego sells for about $220. What's kind of crazy about this is they offer you, basically along with pretty much every single resolution you're ever going to have if you want to experiment with high-def audio. They offer 3 different oversampling filters that you can choose between to fine-tune the sound just the way you want it. If you want to get some serious nerding on, they have it's called a headphone. They call it a headphone blend mode, and the idea is they cross over some of the sound from the left to the right and the right to the left to make it feel like you're more in a room listening to speakers and less like you're listening to headphones. You'll either love that or not love it. You will need to download and install drivers for the best results on that.
Okay.
And one more before I go is Shit's Fulla. Shit makes me laugh. $79 for this US-made device. It's an AK4396 DAC and pumps out 200 milliwatts of power for up to 32 ohm headphone loads. Really a steal for the money. It sells for like $79, and it's pretty nice. It's not going to drive planar magnetics, I don't think, particularly well, but then again, almost no small USB powered headphone amp does a great job on that. That's what's really interesting about the AudioQuest Red is because, planar magnetics just want all of the power. Some of the newer ones, not so much, but most of the ones you see, out there, will drive almost any headphone you have great until you get to like a Hi-Fi Man, planar magnetic or whatever. I've been obsessed with planar magnetics this year, but I've been obsessed with other headphones too.
We did get some more solar suggestions, and one was actually for a stove. Noel wrote, ask at TekThing.com. All of Biolite's products are amazing as they have the ability to charge nearly any USB-powered device. Their camp stove generates energy by burning biodegradable material. They also provide their base station for families in developing countries in an effort to cut down on the use of coal fires for indoor cooking. I own their camp stove and plan to buy as many of their products as I can afford, as you can never have enough dual-purpose off-the-grid power. Below is some product info. I hope this finds you guys well. Love the show. Keep up the good work, from Noel. Or maybe it's Noel, if you're a dude.
Noel, judging from his graphic, I'd say he's a dude.
Dude. Sub-dude. So he did include a link below to the Solar Panel 5 Plus. I haven't tried this one.
I have not tried this one either.
It looks really cool, though.
I like how they have like the little aiming mirror on there. That's pretty cool.
That's pretty sweet.
Well, aiming's pretty important, and also
very important.
If you've never seen one, this is the Biolite base camp.
Awesome.
I've been fascinated. It's basically a rocket stove design. I've been fascinated by this idea for years. They do smaller stoves. All of them have in common they use heat to generate electricity on these stoves, although I think it's only a 5-watt maximum output.
Yeah, I actually got to test these on a previous show as a review product, and I totally agree. Like, the wattage is so low on it that it charges things really, really slowly. But I think it's awesome that they're able to do use that charging capability from biodegradable materials. That's so awesome.
It's a little tiny wood stove or
It's
grass
a tiny
stove.
wood stove, yeah.
Oh my God,
You
or
just
stick
toss things
stove.
in the bottom, and then the heat is very contained, and it charges your things
Charge all the things slowly.
slowly.
Well, yeah. Well, it's in trouble with like some of the latest model phones and some of the latest model tablets
Yeah.
will take forever to charge, if at all, with a 5-watt charger.
Oh yeah.
Oh my goodness, this is the part of the show where we remind you, once in a while, put away the phone, step away from the screen, close the laptop, and do something analog. Like take a walk while a script spoofs Pokemon Go into thinking you're walking around Central Park for 24 hours a day at 20 kilometers per hour. Allyn, you remember Allyn, he said you can hit level 23 in 4 or 5 days doing that. Yeah,
Did he do that?
maybe.
Cheaters, man, cheaters!
Well, he was torturing an office mate.
Oh my gosh, that's horrible.
Maybe you should
but
do something
awesome.
analog, torture someone in the office. I'm Patrick Norton.
I'm Shannon Morse.
We'll see you next week on TekThing.
I feel so behind on Pokemon Go because like I've been working so hard lately, and when I went to DEF CON, definitely not turning on Pokemon Go once that I was out there.
Well, that was one of the big things they were talking about, tracking people using Pokemon
Yep.
Go. Allyn was saying that one of the, I guess the back home, they had video of police copters, like
Yeah.
trying to figure out, like somebody called into this car, was driving
Oh, no.
slowly and then like doing 180s and going down alleys. And you know, they finally get an officer on site, right? Because they got the full-on, like, you know, LA style, like helicopter with a giant light
Yeah,
on it.
totally.
And you know, pulled the guy over, and he's like, "Yeah, I'm playing Pokemon Go, officer." And the officer's like, "Hey, you keep driving safe, you know. Don't
Yeah.
be surprised if people keep calling
At
the
least he
cops
was
if
going
you're."
slowly and like stopping and stuff.
I guess it was the wee small hours of the morning. I'd like to see
Yeah.
the video. Just
It probably seemed like he was like, I don't know, camping around and checking places out or something.